Hello everyone, my name is Yashaswini, currently pursuing BE in Sri Venkateshwara College of Engineering. In this video, we are going to see about the transaction processing, introduction to transaction processing, transaction and system concepts from the subject called Database Management System. Now we will see the introduction to transaction processing. Transaction processing is a critical component of modern computing, enabling the efficient management of business logic and data integrity. It involves a set of information processing activities in which the result of each are preserved if the entire set is completely successful. This ensures that data remains consistent during and after the execution of related operations. From online shopping transaction to final operation, transaction processing plays a crucial role in ensuring the reliability and accuracy of critical systems. Now we will see what is transaction. Transaction is nothing but the data manipulation, atomicity and consistency, isolation and durability. Data manipulation. A transaction represents a single logical unit of work comprising one or more operation on the database. It could involve data insertion, update, deletion and retrieval. Atomicity and consistency. Transactions are designed to maintain the acid properties, ensuring atomicity and consistency of the entire set of operations. Isolation and durability. Data isolation and durability are fundamental aspects of transaction processing, ensuring the integrity and reliability of the data involved. Now we will see the characteristics of a transaction. Atomicity, consistency, isolation, and durability are the characteristics of a transaction. Atomicity. A transaction is atomic, meaning it is all or nothing. If any part of the transaction fails, the entire transaction fails and the database status left unchanged. Coming to the consistency. Transaction brings the database from one consistent state to another consistent state, preserving the integrity of the data. Then isolation. Transaction should operate independently of and transparently to each other, ensuring that the concurrent execution of transaction does not create data inconsistency. Durability. Once a transaction has been committed, its change persists even in the event of a system failure, ensuring data integrity and reliability. Now we will see asset properties of transaction: atomicity, consistency, isolation, and durability. Atomicity, which represents the all or nothing property of transaction, ensuring that all include operations are completed successfully or none are carried out at all. Consistency, which ensures that the data remains consistent before the transaction, after the transaction, and during the transaction. Isolation, which ensures that the execution of transaction in parallel does not create data inconsistencies. Durability, which guarantees that once a transaction has been committed, the changes it makes to the database even in the face of failures. Now we will see the system concepts in transaction processing. First one is transaction manager, second one is concurrency control, and the third one is recovery management. Coming to the transaction manager, which is responsible for managing and coordinating transactions between multiple users and applications, ensuring the database's integrity. Coming to the concurrency control, which enables multiple transactions to execute concurrently without compromising the data integrity and consistency of the database. Recovery management, which mainly focuses on restoring the databases to a correct state after a failure, ensuring that the transaction survive system crashes. Transaction manager. In transaction manager, we have transactional metadata, deadlock detection, resource synchronization. Transactional metadata. Transactional managers store metadata on the status of each active transactions, ensuring visibility, and management across the entire transaction lifecycle. Deadlock detection. They implement mechanisms to detect and resolve deadlocks, which can occur when multiple transactions wait or each other to release resources. Resource synchronization. Transaction managers handle concurrent access to resource and ensure which are executed efficiently without conflicts. Now we will see concurrency control, lock-based protocols, timestamp ordering, multi-version concurrency control. Now coming to the lock-based protocols, concurrency control mechanisms utilize lock to prevent multiple transactions from accessing the same data concurrently, thus maintaining consistency. Timestamp ordering, which imposes a total order among transactions based on the timestamps assigned to them, avoiding conflicts and ensuring proper serialization. Multi-version concurrency control, which allows different transactions to read and write different versions of data, ensuring consistent and concurrent access without locking. Recovery management. In recovery management, we have transaction logging, point in time recovery, checkpointing. Coming to the transaction logging, which logs are maintained to record every database modification made by transaction, crucial for restoring the database in case of a failure. Point in time recovery, which enables the database to be restored to a specific point in time, facilitating the recovery of data as it existed at that particular moment, useful for historical data auditing. Checkpointing, which provides a mechanism for periodically saving the state of the database, minimizing the amount of data that needs to be recovered in the event of a failure. Transaction processing monitors. We have monitoring, fault tolerance, coordination. In monitoring, tracks the execution of transactions, which collects performance metrics and ensures the predefined services level agreement. Fault tolerance, which employs mechanisms to handle system faults and recover from errors, ensuring continuous and consistent transaction processing. Coming to the coordination, which coordinates the execution of distributed transaction across multiple nodes, ensuring their atomic and coherent execution. Distributed transaction processing. In distributed transaction processing, we have location transparency, which enables the use of distributed transactions without the need to specify the exact location of the resources involved. Resource sharing, which facilitates the sharing of resources across distributed systems while maintaining transactional consistency and integrity. Concurrency control, which ensures that multiple distributed transactions do not interfere with each other, preventing data inconsistency. This is all about the transaction processing in database management system. I hope the video was informative for you all. Thank you for watching.